All right, so now moving on. Now, storyboarding saves lives. We're going to be discussing Project Esther. So, definition of process redesign: it is a systematic rethinking of clinical workflows to improve safety, quality, and the efficiency of the project that is at hand. So, the concept of Project Esther is it was basically a Swedish initiative integrating the hospital and the community care for elderly. So, they used storyboarding and process mapping to identify gaps and design data flows. So the results were that the number of admissions reduced, number of wait times reduced, and the patient satisfaction overall increased. Right. So the key principle used here was technical interoperability must follow process interoperability. For example, mapping to FHIR, admission avoidance meant that we are avoiding admission into the hospital. That means that early home monitoring only is applied for the elderly, and that means that FHIR observation and care plan is shared between the hospital as well as the community systems. So that is an overall plus, and that will cause patient satisfaction and also less admission into the hospitals, because we are already diagnosing whatever problem they have early on at an earlier stage rather than waiting for a later stage to come. Pitfall here was assuming standard adoption alone. For example, installing FHIR API guarantees better care. Without workflow redesign, benefits rarely appear. Now, question: what lessons from Project Esther apply to health IT projects? Answer is: start with process mapping and storyboarding, involving all the stakeholders, and then choose the technical standards. Now, conceptual model, and a meta model. What these are? So, definitions: model is basically an abstract representation of a system's elements and relations. Meta model is the model of models. It defines how models are built. That is the grammar of modeling. For example, meta models are UML. UML is a unified modeling language, which is a meta model that defines class, attribute, and association. Then you have HL7 RIM, which is the reference information model, which is a meta model for clinical domains, right? So a model is basically an abstract representation of systems, elements, and relations, while a meta model is the model of models. That is, it defines how the models are being built. That is the grammar of the modeling. Now, meta model types. So first type is functional, which means the system, which entails system capabilities. For example, order lab tests use case. Then we have technical meta model, which takes care of the technical or technological components. That is REST API, FHIR server, where REST is basically representational state transfer. API is application programming interface, right? Then we have organizational for roles and governance. So, for example, data custodian is hospital IT. Then data type of meta model is basically going to take into consideration the entities and the attributes. Then the example in healthcare is patient observation and encounter. Then business process relates to the activities and flow. For example, admission to discharge, the whole flow is basically managed by the business meta model. Then we have integrated IS, which will uh, see the whole enterprise view, and that would be the hospital EHR ecosystem. So, example storyboard: data meta model classes patient observation and condition. Then transform FHIR resources with profiles. Pitfall is mixing levels. People describe data details while drawing process models, which leads to confusion. Now, define meta model and explain its role in HL7 RIM, which is reference information model, and FHIR, which is fast healthcare interoperable resources. So, meta model provides formal structure, that is classes and attributes from which domain models FHIR resources are derived. System use cases, actors, and scenarios. So, the definitions firstly: use case is basically a specific goal oriented interaction between an actor and a system. Actor is a person, device, or any system that would be interacting with the system. And a scenario is basically concrete instance or sequence realizing a use case. For example, a use case could be record vital signs. Actors could be the nurse, that is the user, and EHR is the system. Scenario is at 8 a.m. Nurse enters patient temperature, then EHR creates an observation, and then the system notifies the physician. Right. So in FHIR terms, we have these three elements. First is use case, which is a bundle of interactions. Then we have the actor, the client app, or the practitioner role, and the scenario, that is test script or workflow example. Pitfall: forgetting secondary actors, for example, audit service or terminology server. Now, differentiate between actor and scenario in HL7 FHIR modeling. So, actor basically is related to the role that is being performed, while scenario is a temporal sequence involving one or more actors executing a use case. Now, functional versus technical components. So, definition: functional component is basically the logical feature delivering value to a user, while the technical component is the software or hardware mechanism implementing that function. Now, example mapping: functional would be patient registration, and its technical realization or technical mapping is the FHIR patient resource plus the post request for the patient. Then order entry, FHIR service request API. Then lab results view, FHIR observation search. Authentication, which is functional, and technical realization is OAuth 2.0 authorization server. Now, what is the concept? Separation of concerns. Describe what before how to maintain the flexibility and interoperability. Pitfall is designing APIs before confirming functional alignment with clinical workflow. Now, give an example mapping of a functional component, medication reconciliation, to its technical components. Function is compare home and in-hospital medications. Technical is FHIR medication statement plus FHIR medication request APIs plus terminology service RX norm. Technical model and organizational model. Definitions. Technical model is the architecture of system components, connections, and interfaces, and also the standards used. While organizational model is the roles, responsibilities, governance, and data ownership. Right. Example, technical would be the client app, API gateway, FHIR server, database, while organizational is the hospital owning the data. Regional HIE maintains the master patient index, and consent authority manages sharing. Now, relationship is organizational constraints like policy, privacy law, drive the technical design, for example, data partitioning, access control, right? Pitfall is ignoring governance. Technically perfect, but legally non deployable system, because if we ignore governance, we won't be able to deploy all these systems legally, right? Now, how does organizational governance affect FHIR architecture in an HIE? So it determines the determines trust framework, identity provider, consent workflow, and thus influences the technical models like authorization server placement. Now, data model UML representation. So we have some definitions. First is entity, which is a real world object of interest. Then attribute is a property of an entity or a characteristic of an entity. Association is basically the relationship between entities, and cardinality is the multiplicity. That is whether it is a one is to one relationship, or a one to n relationship, or n to m, which is many to many relationships, right? And one to n is one to many. Now, UML class patient, FHIR resource mapping is patient, and key attributes identifier of the patient's unique identifier, that is the ID that they get, then the name of the patient, the birth date, gender, age, all of these. And encounter, the key attributes are period and the reason code, right? So what exactly the problem they're facing, whether it's a disease or a condition, right? And the period for which it has been run, oh sorry, it is being it has been bothering them. So all of these things noted down for encounter. Then observation code, the unique code for the observation, the value, and the effective date time on which it was noted, the observation was noted. Cardinality, patient one to many encounters. One star encounters means that patient is one and the number of encounters is many, right? So that is the representation. Then encounter, one is two observations, one is to many observations. That means that one encounter can show many observations, and one patient can have many encounters in the EHR. Practical tip: normalize shared elements, for example, code systems, but denormalize read optimized copies for analytics. Now, pitfall is designing data models before agreeing on canonical vocabularies like SNOMED and LOING. Semantic causes semantic mismatch. Now, explain how UML data model multiplicity maps to FHIR reference cardinality. Right. So, how the UML data model multiplicity maps to the FHIR reference cardinality. So, UML one is to start translates to reference list in FHIR, which, for example, means encounter dot observation is an array, right? Now, moving on, business process model, activity and sequence diagrams. So definition: business process is a set of related activities producing a service or output, and the activity diagram is a flowchart modeling the control flow. Sequence diagram is a timeline of interactions among the actors of the components, and the state chart is a life cycle of an object, that is states plus the transitions. Example: lab order process. Activity is order test, then collect sample, then perform the test, then record result, and then notify the clinician. Sequence is clinician app to FHIR server, post service request, then LIS, FHIR observation, and then EHR. FHIR connections. So each step corresponds to a resource creation or update, and often a subscription, that is a notification. Pitfall is that ignoring asynchronous nature, lab results arrive later, which means needs event messaging or polling. Now differentiate between activity and sequence diagrams and give one healthcare example of each. So activity shows, basically activity is this and sequence is this. Activity shows workflow logic. So you see the workflow that is being performed, while sequence shows the actor interactions, right? You can see the actor interactions. Example: triage process activity versus lab order exchange, that is a sequence. Now, other approaches from storyboarding, prototyping, and tools. So, what is a prototype? It is a preliminary model of a system for testing ideas and exploring the project more. Wireframe is basically a simplified UI user interface layout showing navigation, the basic navigation, and mostly we use apps like Miro or Figma to produce the wireframe. Now, process mining is algorithmic discovery of process models from event logs, and user research is methods involving interviews and shadowing to understand real tasks. Example workflow: prototype a vital sign entry screen, then gather nurse feedback by interviewing them, then iterate, and then formalize data elements, and then finally map to FHIR observation. Tools example, as I said, we use Figma as well, Miro, then Balsamic for UI, then BPMN modeler for the process diagrams, then Camenda for process execution, and Jira plus Confluence for requirements tracking. Pitfall is scaling prototypes, which leads to end users rejecting the final UI. Process model is not equal to the real practice. Explain how process mining complements storyboarding. So it basically reveals actual data-driven flows. Storyboards validate or redesign the intended flows, right? Now, Diagram types, activity, state chart, sequence. So definitions and notation we'll go through. So diagram for activity, key elements, actions, decisions, fork, join, or swim lanes used for workflow logic. Then state chart, states, events, and transitions. These are included in a state chart, which shows the object lifecycle. And for sequence, the key elements are lifelines, messages, or activation bars, which is used for interaction timing. Now, an healthcare example that we'll cover is activity, vaccination, clinic flow, register, then consent, take consent, then vaccinate the person, then observe what happens, and then finally, if there are no negative effects, side effects, or basically there is a negative, coming from the vaccination, sorry, the reports come out to be positive, then we discharge. Then state chart, service request state, draft, then active, then completed, and then cancelled. Sequence, EHR post or service request, LIS acknowledgement to LIS post observation, and finally EHR acknowledgement. Pitfalls: missing exceptional paths like test cancelled, and no timeouts or retries in sequence diagram. Draw sequence diagram for the medication administration using FHIR. So medication administration resource, using this FHIR. This is the resource. Expected is we first make the patient app, then EHR post medication administration. We call the post request for this resource. Then pharmacy system acknowledges it, right? And then finally inventory updated. So graphical models make requirements testable. Every arrow can map to FHIR operation and test script.